Hello, in this video I'm going to show you part 2 of real-time destruction with Houdini and Unreal. So in part 2 I want to make something a bit more useful and complex. So here I have this scene and I can basically shoot with a gun barricade. So you can see where I shoot, I will actually explode or break the barricade. So this will specifically only be in a few areas. So as you can see, like it's not everywhere. And this can be useful for a gameplay example. Like a good example could be Borderlands or The Division 2. So here in the Division 2, you have like this cover system and you maybe don't want to destroy the whole barricade. So we can specifically in Houdini say where the destruction needs to be, and then we can focus where we need to simulate damage. So before I start, this video will also require you to have some basic understanding of Houdini and Unreal, like blueprints. So it's very useful in this video. And also watch part 1, which is like a very basic overview of how to do a basic destruction. So here I have my project and I can press play and I have the default starter gun from Unreal. And if you don't have this in your project, you can go and import this and you can import the first person blueprints. So either make a new project or import them here as a first person blueprint so you can have the same result as I have. Then we also want to modify some of that blueprint. So this is the base blueprint you see here, and I added here a line trace by channel node. So we'll shoot some rays. So this is the only thing that I've added to the system, so nothing else that I have changed there. So basically, whenever I click, we will play the animation, and then I will also shoot a ray between two points. So we have sphere 1 and normal sphere. So if I would go in my 3D view here, we have sphere 1. And this is basically attached to my gun. So I'm shooting from my gun to a certain point. So to make things easy, I just added a point here in my 3D view. So this is basically how far I can shoot. So everything that is farther from that from these spheres, I cannot shoot or destroy. So they have to be in between these two spheres. So this is a simple way of setting up a ray trace. You can also do other ways to shoot further and so on, but this is just like a quite simple way of doing it. I also added a debug mode and added the color yellow. So every time I press play now, I can basically shoot these yellow lines. So this is mainly like for debugging purposes, nothing special there. So it's just knowing where I shoot. So make sure to enable here the debugging to a duration so you can actually visually see where I'm actually shooting. Then the other part here is then our 3D geometry. So I used some geometry from Megascans. As you could see here, this barrier is a Megascan model. So you can get these as well. You can make your own model. You can get a model from a current project. You can use any model you have and follow along here with me then. So this is what I'm going to use for my demonstration, the barricade. So with this barricade, we can then click and create a destructible mesh. As in the last video, we just have here our destructible menu. And of course, we want to import our FBX chunks. So we can have a custom fracturing from Houdini in here. Now let's jump into Houdini. And we're gonna now first of all import our geometry. So I'm gonna use a file node, import that FBX file. Then also I want to scale this down because there is always 100 units difference in scaling. So I'm going to scale this down by 100. So now my model is in a better scaling. So you can see that here I'm having a quite large scale. You can see the values on the grid, like they are quite large scale. So if I would now scale this 100 units down, it's like a more, it's just like better units to work with here. So I always like to do that just to make sure we are working consistently with units in different software. Now, let's talk a bit about the fracturing, and we can use our fracturing from the last video, so material fracture, so that will work as well. We can delete a second level, and we can add some more fracturing here. What we can also do to easily visualize the pieces is here, click on the attribute you want to visualize, so we can actually click on these different attributes and visualize them in the viewport. So you can see this is now what we have. And we notice that the destruction or the pieces are a bit placed weirdly, like they're all more in the middle there separately, and we can change maybe the noise here to a permanent noise, and I think that's a bit better, a bit more like distributed along the shape. So we don't have like specific clusters, so it's everywhere a bit bigger pieces. Then I also want to show you some other ways of fracturing. And another way you can do fracturing is by using the Voronoi fracture. So this requires a bit more work, so we need to input custom points for fracturing. So each point represents a piece, a debris piece or chunk. So if I would place down a scatter and lower this to like 70, we then have 70 chunks here. So you can see we have also now fractured this quite similar to a material fracture, but a bit in our own way. So you can see this is another way of fracturing. And once we change the points, we will also change the fracturing. We can also, for example, do a relaxation. So relaxation means that the pieces are more equally distributed along the mesh. So you can see that the pieces are a bit more equal in size. Or we can also, for example, place a transform and play around with the points. So if I would now rotate or scale the points, we will also influence our chunks here. So you can see we can really start playing around with these fracturing types by just moving around points. So that can be quite interesting sometimes to do. Now we can also make this a bit more advanced and bring a mask here. And we can actually paint where I want more or less chunks. So here I'm going to paint the corners for more pieces. And we can now have a mask attribute. So you can see we have a mask. And now instead of using that 70 points, we can now fill in our attribute. So we can disable here force count. And now we can just enable here an attribute, and we can just type in or select our mask here. And now we will have only points where our mask allows it to be. So if I would increase here the density, we are not coming out of our painted mask. So you can see if I keep painting here the top side, we have now more area for scattering. So this can be really interesting overall. If you want to have something super specific, you can do that here as well. So let's visualize that here. And we can see that we have a lot of different smaller chunks at the corners of our geometry, and then bigger chunks nearing the bottom. So this can be overall interesting if you want, for example, the borders of your destructible mesh to be smaller and the core of your mesh needs to be bigger. We can, for example, do something like that where we can manually figure out where things should be larger in size. So that was one way. Now, there is also another way that I want to show you, and this one is also pretty interesting, and that is called the Boolean fracture. So this is also a node here. So we're going to plug in here our mesh again, of course. And we also then need some fracturing geometry or surface to calculate fractures from. And we can do this by drawing. So we can draw lines and curves for fracturing. So here by default, I can just like draw on this grid, this blue grid, but I can also go to projection mode and set it to screen space. So whenever I draw, it will be based on my screen or camera angle. So if I change my camera angle, I would draw a different line. So what I want to do now is fuse the line. This is just to simply reduce overlapping or close points. So increase that. And I also want to do a sweep node, so give it some geometry. So with the sweep node, we're going to have to change a few things. And I want to be a ribbon. And I want this to be only one column, and the width needs to be larger. I think it needs to be maybe 5. So we have like a large ribbon here. So every time I draw, I will basically draw this piece of geometry. And I also want it to be rotated. So we're going to go scroll down, and on the rotation, we can then fill in here 90 degrees. So we can now use this as input for my Boolean fracture. So I'm gonna also make sure that my fuse has a decent value, so that it will just help later on if you use this method. So let's plug that in the Boolean fracture then. And we can now basically cut pieces from my mesh by drawing. And I'm gonna visualize this by also using a explode view here. So explode view. So you can see that we can now basically start cutting pieces. So I'm gonna go back to drawing, maybe clear all the results. And once I start drawing now, I can cut my barrier in pieces. So this can be quite, again, useful way if you want to have something super specific. You can just start drawing and cutting the geometry yourself. So this can also be something that might be interesting to you. So as you can see, we can draw that. We can draw something super specific, like if I only want that part of a corner, you can do that as well. So these are 3 ways that I just wanted to show you. So each way has something interesting in there, but I'm gonna for now stick also with the material fracture. But I just wanted to show you that there are so much possibilities for fracturing in Houdini. But I'm gonna here stick with material fracture and prepare this for exporting. So now back to our material fracture piece, and we're gonna go to our labels and enable here the name so we can actually see our pieces back again here. And I might increase the amount, so maybe let's go to something like 80, so we have more geometry to work with. And then I want to clean that up. So I want to also merge specific parts together. Like again, maybe you want some still a cover spot for your gameplay or some art directable parts that doesn't need to be destroyed. So I'm going to first of all assemble the model, and with assemble I can pack the geometry. So packing actually means that all the pieces are now represented by a point basically. So they are all stored or packed in one. So you can see here I have all the points and now I only have one point. So with that is actually useful for selecting pieces procedurally. So I can place down a group node, and in this group node, let's give it a better name like static. And also want it to be a point group, and this doesn't need to be base group. I want to be bounding region. So with the bounding region, I can automatically select pieces, as you can see here, that are inside that cube. So if I generate something, everything inside the cube will be seen as a static group. So now I want to actually then make this a bit more advanced. So we have different options to input custom options here. So I can use my second input here and, for example, place a box myself. So place box next to that here, and I can plug that in over here and that will work. But I also want to have a sphere. So I can merge these together and I can use this as input. So maybe let's change this shape here of the box and also from the sphere then. So I only wanted the bottom to be selected and also the sphere here. Let's maybe turn this into a poly and lower this in scale. So I only have destruction then in the corners. So in the group itself, I'm going to have to change this from bounding box to bounding object. So we're going to use our input object here. And we can actually see a small issue here. So when the two geometries, my sphere and box, are overlapping, I actually have a issue with that it is not perfectly detecting these two together when overlapping. So what we can do here to fix that is we can actually turn this into a volume. So ISO offset, you can also just merge this with a boolean or do other things, but I often would use here a volume. So let's use a 50 in samples here, so it's a bit more detailed. And we're going to use that as our input now. So I'm going to also change this then to bounding volume because this is now a volume. So by default, it's not working out of the box, and we're going to have to fill in here a 1. So ISO offset 1, and I'm also going to click then the invert because now I'm seeing the other result. So when I invert, I have my correct result. And this is exactly what I sort of wanted. So we only have now the sides not selected. So I can procedurally now play around with the shapes, and my group will automatically update. So maybe I can drag down my sphere a bit lower, and now I have this interesting shape. So this is the part that is not being destroyed in Game Engine. So this will be not destroyed. So this is a way to art direct a bit the area of where I want it to be. So if I want it to be the corner, I can just grab my sphere, and you can see that the corner is now selected. This is some basic procedural group selection. Now next up, I want to clean up this geometry. So if we look inside, we still see that we have a lot of geometry from that fracturing. So I want to make this a bit more optimized. We don't need all these chunks, so I want to optimize and clean this model up. So there are a few different ways of doing that. And I'm going to use a way with only a few nodes. So I'm going to use the cleanup destruction tool. So this will clean up the model. And if I plug this in here, it won't work out of the box because it is expecting a simulation of a destruction. But right now we don't do any simulation. So you can see by plugging this in here, all the insides are automatically deleted and cleaned up. So that's actually what I'm looking for, is something that can clean up our tools here. So what we can do here is we can, for example, do a small simulation. So I can grab our bullet solver, and we're gonna just set up a very simple simulation here. So when I press play, the box here of my barricade is falling down. So what I want is a ground plane. So ground plane. So when I press play, it will just like fall apart. But I don't want all the pieces to be falling apart. The static group doesn't need to be simulated. And we can actually quite easily do that by defining a attribute called active. So we're going to create a attribute. And this attribute, again, this is only for static. And we're going to call it active. And active needs a value. So when active is 1, it's simulating. When active is 0, it's not simulating. So we need to be very thoughtful of what we fill in here. So I want to fill in 1, but I want to invert my static group. So static doesn't need to be active, so it's value 0. So you can see here that now only the side pieces here are destroying or falling apart. So now to make things a bit more interesting, we need to add some forces here in this tab. So let's fill in some values to work with, mainly here in the gravity. When I press play, they just like fly off. It doesn't have to be special, but this is like the result that I want. So if I plug this in now in the destruction tool, in the destruction cleanup, I basically have the result that I wanted. So if I go into the mesh, it's now cleaned up fully in the inside. And I can clearly see that the colored pieces will be unique and separated. So that's basically what I was looking for. So only with a few nodes, I quickly clean this up a bit more. So the less pieces, the better probably for the game engine. So it sometimes can be a good idea to clean up. And also this can be also useful for art direction. Like some parts don't need to be destroyed, or some parts need to be larger. So we can fake that here a bit in Houdini already. So the thing that I've not talked about is the UVing. So let's place a quick shade and start checking our UVs. So here we have our UV that looks good, but what if I do a exploit view? So here, let's check our UVs on the inside, and they are okay, but they could be better. So we might want to build our own UV system. They are not bad, but they could probably be better. So let's try and find a way of making this a bit better. So what we can do is we can, for example, use the UV flatten. So this will automatically then unwrap. You can also use the auto UVing from labs, which I can also heavily recommend trying that out. I'm just going to simply use here the UV flatten as example. So I want to then only unwrap the inside pieces. So I'm going to plug in then my geometry now. And in our UV view, we can see we have unwrapped that piece. So they all look like that. But I also only want to unwrap the inside pieces here. So the group is inside pieces. So I'm going to keep my original result here. So if I would now view this here, this should be a bit better. I mean, it's still not perfect, but it's definitely like a bit better in some areas. So if I also view my UVs here, let me maybe grab this apart with the blast node. So we can just simply blast away these inside pieces and then invert that. So this is my normal UV of my model. And then this is my debris pieces of the inside. So these look okay. They are nicely flattened by the node. Again, you can also use the auto unwrapper from labs. That will work as well. So with that, we can also maybe specifically target this in an area. So we can use the layout node, UV layout. And with the layout, we can then specifically say where the inside pieces need to be. So I can also use the group here inside, and I can use my handle, and I can specifically merge or force this in a certain area. So here, if I want this to be in this specific area because this texture is used for that, I can here do that. So that can be quite useful. So I'm going to use the area for my barricade texture as well for my texture for the chunks here. So this is then overlapping with each other. So you can see that they're now in there. And this is basically then the result. So just these two UV nodes to quickly add some better UVing in there. And to make sure my UVs are getting transferred, I'm going to also enable here the UV transfer in the packed geometry just to be sure that we have that. So in the end, we should output a piece with UVs. So here we see our final barricade. And if we unpack this geometry, because here this is still packed, we should see now a piece with our UVs. So you can see that we now have everything as it was before, but now also a bit more cleaned up. So maybe I can quickly go back here and tweak the UV space. And then I have my new result here. So that's basically it, and we're almost done with the Houdini part. So let's think about using a FBX node. And again, from last video, we need to use the attribute to define the exporting. So we're going to use here pad. So let's do pad here because the pieces are done separated. Let's give this also a proper location to save. And also let's scale up our model back to 100 units. So that's also important to do that as well. So then we can click save. We only need to render one frame. That's also important. We only need to render one current frame, number 1. We don't need to render the whole timeline, and then we can save that. What is also interesting to do is we can also triangulate the model. So we can use the divide node, and in the divide node we can enable some triangulation. So that can be very useful for complex geometry. What we also notice here is that we are actually still working in a packed environment. So that means that we cannot edit geometry directly. So we need to unpack that geometry. So if I unpack the geometry, I can now actually see the total amount of polygons. And we are basically done with our model. So the cool thing about Houdini is we can always go back and forth between nodes. So I can go back to my original fracturing node, and in there I can basically start changing values. Like I can change the seed, I can change the way the fracturing is done, and so on. Now back in Unreal, let's go and import our model. So I'm going to open my destruction mesh, and I'm now going to click on import our FBX files. So I'm going to select here my debris pieces, import, let's take a moment, and then here we have our model. So we also need to add our materials back again now, but we can see that we have our, we have the exact same result in from Houdini and Unreal. So that works perfectly. So now let's go and scroll down and add our material. Under skeletal mesh, we have here some options for materials. So I'm going to use the same material from my original mesh because it's the exact same one. So I can just write it in there. And then we have the destruction mesh. So this is what we had also in previous video. But now I also want it to be actually a blueprint. So I'm going to delete this back again in my scene. And I'm going to create blueprint. This can just be an actor. Just call it something like barrier destroying or destroyer. And in that blueprint, we can drag and drop a destructible mesh. So now we have that mesh in there. And the cool thing here about having a destructible mesh in the blueprint is that if I scroll all the way down here, we can have custom events here for when something is fracturing or breaking. So that can be quite useful to have or to trigger something else. So whenever the mesh is breaking, we trigger something like a particle and so on. So this can be quite interesting to just have in a blueprint. So now I'm going to use my blueprint in the scene and not my destructible mesh. So in the destructible mesh, there might be some more settings we want to tweak. So mainly talking about the damage threshold. So we can maybe increase that so it takes more damage for it to break, and the damage spread, I'm going to leave it like that. Now we can also go a bit more down, and we can also again fill in the support depth 1, so we have a bit more better simulation. And what's also now interesting is if I switch to my depth 1 with all the chunks, I can actually start clicking these chunks. So I can select, for example, my big chunk here, and I can now say that this big chunk is a support chunk, that this doesn't need to be fractured, don't take any damage, and do not crumble. So we can say that this specific chunk basically is quite static and will barely be destroyed or simulated. And that's also the reason why in Houdini I made this as one big chunk, because now I can just click on this and say this is a support piece, don't damage this. We can also like select other pieces if we want to, like we can also select multiple and also add them as support and not damaging. But the main reason in here is just I have one piece, click it, say it's support, and done. Then one of the final things to do here is to actually write a logic when I shoot on this barrier, it starts to breaking or falling apart. And that is done in the blueprint here of the first person. So here from the line trace, we actually gonna use something that is called damage. So we can apply damage on a point, radius would fall off. So we have different methods here for damaging. So in my video here, I'm gonna use here then the point damage. But you can play around with these other ones as well. But I'm gonna just simply use points. So I'm gonna only damage in that certain area where I shoot. So let's play that in over here. And then we need some information to work with. So if I would compile it, we need more data to work with. So the first thing what we can do is we can link our hit with the hit results here that it needs. So that's one part. And then we also gonna break our hit result. So we have some more detail here. So we have specific detail about the raycast here. So the damaged actor is the actor that is hit. So whenever we hit that actor, we apply some damage. Then also the location is basically the location of the impact. And that's basically now done. So now we are doing damage. But what I've not set up is the amount of damage. So it's currently 0. So if I would play and if I shoot my barricade, nothing is happening because I'm doing 0 damage. So we need to do more damage to start breaking this. So if I would fill in the high value, like 50, and now start playing, I'm now being able to destroy this barricade. As you can see, we're now basically shooting and destroying that. So what is important here with these damage numbers is if I, for example, would now fill in 10, this will not be destroyed. And the reason for that is this is directly linked to my damage threshold here. So in here I had 20 damage. So if I would now have 21 damage on my gun, I'm able to destroy the barricade. So this allows us to have specific damage values on different models, or this allows us to have multiple guns or weapons with different damage properties. So we can now start playing around with our damage number and have more variation for gameplay. So every different gun, or if I have a gun that charges, we can then have different damage outputs. But this is basically how you can set and do damage to that object. Now the final touch here would then be spamming a particle. So for that we're gonna go back to our barrier, and in our barrier we're gonna add the particle here. You can also try and adding the particle here in the first person blueprint, that's also possible, but I'm gonna here specifically use the event here for fracturing. So if we scroll down here all the way at the bottom, we have this specific event on component fracturing. So here we can actually spawn particles on that. So if I would now type in spawn, and we're going to use spawn system at location or emitter. So emitter is the default particle, but we're going to use system at location because I'm going to use the Niagara systems. So here we can now select particles. And we can now use the hit point as my location, and that will perfectly work. So now let's talk a bit about the particle. So here I have a basic particle, and the way I've built this is by using the Niagara system. So I'm going to right click, effects, Niagara system, and I started from a template called the burst. So here radial burst is basically the exact same particle that I've used as well. So here if I open that, we will now see like this burst. So every time we hit the barrier, it sort of like has that small explosion or burst. So that's what I basically have done. So I actually made a few more tweaks to my version. So if you can see that we are actually bursting a model instead of a sprite. So you can see that these are now like debris chunks. So you can see that I removed the sprite and I added a model. So that makes it a bit more cooler. So we actually have like small debris chunks there. So you can see here is the default one from Unreal. So just add a mesh renderer. What we can also do then is copy paste that burst, and I use that burst also to then use as smoke. So of course I set the velocity a bit slower so it's not like going all around, but I basically use the same logic for that smoke as well. But I can just recommend you checking out other tutorials for this, for creating particles. There are a lot of particle tutorials out there for Unreal, but this is like a basic view on that. So here we can now use the particle. So you can fill that in, and let's now play, and let's shoot that bash, and let's shoot our barricade. So we can see that everything is now being destroyed, and we are spawning the particle. So it's also cool now if I would shoot my big chunk at the bottom, we are not spamming any particles or breaking anything because again, this is set as a non-damaging actor. And when I shoot here the top, I'm able to destroy that. So if I shoot somewhere else, we're not doing any damage or spamming stuff. So we only specifically damage that barricade. And this is basically how this is working. So right now we are done. So we have a fully working system. So we mainly here used again the Apex destruction plugin for Unreal, but in the future I'm looking forward to what the Gale's system of Unreal 5 will bring. You can already try it out, but I feel it's still a bit experimental. It's not officially been released, Chaos, but I'm definitely looking forward and maybe do a small revisit on some of this destruction. So I hope you enjoyed this video. Thank you for watching. Feel free to like and subscribe. See you on the next one.